Okay, I think we can start. Yeah, I think we should just get started. So hi everybody, and welcome to the 15th Shiny Gathering. Thank you for joining us today, and um, this is going to be so cool. Hi, I'm Gigi. I'm the internal journalist at Appsilon, and today we have Aga, who is one of our wonderful delivery managers at Appsilon, who I am very convinced has superpowers because she's so cool. And also, aside being a wonderful delivery manager at Appsilon, she's also a bioinformatician. So today she'll be talking to us about data analysis pipelines, the advantages and limitations of targets and Nextflow in the life sciences, and everything else around that. And please leave your questions for her in the chat. We'll go over them towards the end of the webinar. And now I'll get out of your way and let Aga take over to introduce herself to us, and we'll get started now. So, Aga.
Thank you so much, Gigi, for introducing. Welcome everybody on this shiny gathering. It's a pleasure to be here. And today I'm going to take you on a journey. And I'll just share my screen so you can have a taste what we'll be going into today. And we will be talking about data analysis pipeline using one of the real case scenario. It's the single cell. So let's get started and let's see what's possible in life science. So you might ask, why do we need pipelines in the first place? Taking into account that the life science field is increasingly data-driven. First, we want to make our life easier as well with some automation. And if the analysis has a multiple step, it's always a good idea to make it automated and not going step by step manually. Secondly, we are collecting and we are generating vast amounts of data from various sources. And here is where data pipeline can help you with not just kind of storage, ingestions and organization of your data, but also making them accessible and manageable for any other steps within your analysis. Also, very important, not only in life science, data quality consistency. In terms of cleaning, validation, normalization, transformation, generally making and ensuring that the data we are using for the analysis on each of the steps is accurate, reliable, and can be reproducible. Then integration of heterogeneous data as we are taking into account various sources, various formats, and not only, but for example, when we do have some integration and taking insight from it, it's very important to have it in one place. Scalability. As I mentioned, big data is everywhere, and data pipelines are designed to handle it efficiently, not only handling, but also enabling scaling your processing, your analysis. Reproducibility, critical in terms of validation and rigor of your findings. Meeting the regulatory compliances, also support for any advanced analytics or any other machine learning that you would like to implement to your analytics part. And collaboration and data sharing, meaning that providing some standardized flow, data formats, and analytics steps. So important to remember is that generally data pipelines in life science specifically, they are enabling efficient not only management of the data, but its integration and analysis. So it emphasizes three key elements that when we are working with data, which is reproducibility, scalability, and maintainability. And this is really important in terms of life science, where each of the steps is also impacting the results and the answers that you're gathering for your questions. So when I was thinking about this talk earlier and before, I asked myself what kind of analysis from my bioinformatics journey would be a great example to show you the benefits of using pipelines as well as challenges that it can address. And I chose single-cell RNA-seq. And why is that? First of all, I personally think it's marvelous, but also challenging data to analyze. Giving you a context, with the single-cell RNA-seq, we can estimate a distribution of expression levels for each genes across a population of cells. So imagine that in the data set, it ranges from hundreds to millions of cells per study, and it can even increase in size every year. So what kind of biological question we can answer here? For example, are there any cell-specific changes in the gene expression profile? Or you can also, it's suited to study like population of cells, identify the type of cells, compare different cell types, and even explore changes in the composition due to disease or other factors, discover new cell type. So it's powerful, it gives a lot of possibility, but with that also comes complexity and challenges. And there are multiple of them. That makes this kind of analysis a great example to use pipelines at all at first place. So we start with high dimensionality. Imagine that your input, what you are getting, and the matrix you will be going with downstream analysis consists of expression levels for thousands of genes and hundreds to millions of cells. Moreover, the data is very sparse, where most of the genes can remain undetected. You have many zeros, and this can be either due to the gene that is not expressed in the cell, real zero, or the gene was expressed, but we were unable to detect it. So we have a dropout that needs to be taken care of. Then batch effect. So not only the analytic step has impact on our result, but even one step before. So how the samples were prepared, processed, sequenced, and it can lead to some artificial differences between sample. Then we have to be careful that during our analytics, we need to take into account that some of cell-to-cell variations are not due to biological, but rather due to technical issues that were caused by that were introduced. And it's very important to carefully plan it in your pipeline as well. Then, as I mentioned, data integration, especially now when we are looking into a great area of any multi-omics, multi-model data, when we can integrate from different sources, from different type points, or even across conditions, it requires not only careful normalization and alignment, but as well as computational resources. A single data set is already large size, and it demands significant resources for storage, processing, and analysis. But also when it comes to the integration and processing multiple samples, so not one, but hundreds. Also, we need to be careful with those resources, and everything that can make us make it efficient way is very well desirable. Algorithm complexity. There are many existing algorithms, different language, different tools, and some of those do not scale well with increasing data sets. Some are not maintainable anymore. Some require some dependencies that are conflicting with others. So the complexity here is a crucial and important matter as well. Lastly, the biological interpretation. We are looking for extracting some meaningful insight from this data. So we need a solid tool, solid pipeline to make it that we can trust its validation, integration, and every single step, as this will impact the final answer that we are looking forward. So as you can see, there are challenges within this particular analytics pathway that also already gives an idea why a data pipeline might be beneficial here to implement. But it's not only that. If you look slightly how the analysis is going, so which steps are there, you can also already see some other challenges that might be addressed using the workflows, the automated workflows, rather than step-by-step approach. This is the first step. So first part, when it comes from raw data, from raw reads to account matrix. This is an example of an NF core, from the community of the Nextflow, one of the pipeline called RNA-seq, that's giving you a chance to go from the reads to count matrix. And as you can see already, this workflow, this pipeline has like 5 different ways to get from point A to point B. So when you imagine that without that, you're doing it by yourself or some command line tools, or you're trying to link it, it might get messy. But you end up with a count matrix, and there's even more in the analysis to cover. And this is all the way from count matrix to annotated clusters and beyond. And to do that, you can take advantage of tools that are existing. 3 main ones from the bioconductor packages that are a collection that is dedicated for single cell analysis. You can have also 2 gold standard tools, Seret, which is an R package. And if you are more into Python, you have a choice to go with ScanPy. And both of these toolkits can include the pre-processing, visualization, clustering, differential expression testing. And all of those is also built from multiple steps that you are running one by one, or you would like to also think about parallelization. And what's more is the idea of reproducibility when it comes to including all of those steps and running in multiple times, sharing those data, validating this data. So as you can see, I hope now you can see why I chose single-cell RNA-seq for today's journey, as we can have some multiple spaces where we can take advantage of the context and idea of data pipelines. So let's move to it. And here is when targets and Nextflow comes and help you out. And I want to introduce you to the concept. Starting with targets and the entire package designated to facilitate the construction and the execution of the pipelines. Make Life Pipeline tool very clean and function oriented. And it doesn't only help you in terms of automating your workflow, building it, but also managing the task, caching results, also enabling parallel computing. When you're in the R environment for a time, you just need R, your renv, you go with targets. There is a great documentation that you can start with and start with filling it in for details of your specific pipelines and then run it. But you also have a very powerful management system for workflows, which is Nextflow. And it shares this philosophy that you have many simple command line tools, so small bricks that can be chained together into a complex task. And what's more, and the advantage of it, is that this allows the adaptation of pipelines that are written most common scripting language. So if you're in R, if you're in Python, or you have other tools, you can chain them together into your task and your workflow. Also, it takes advantage for this well-known software tools from the Docker, Conda, as well as execution platforms, not only HPC schedulers, but also main cloud providers. As simple as that. You just need a Nextflow, you need your text editor, you can write your pipeline and execute it by entering a command in your terminal. So now let's focus on the pipeline that it will be the main point of today's meeting. So when targets and Nextflow met Seurat. So I chose a use case, kind of simple and widely accessible data set from peripheral blood mononuclear cells. It is not the biggest one, so we won't be waiting a long time to get it done. And also it can be an example to show you the main features and the examples that you can also take further in your research. So we'll focus on the downstream part when we start with the count matrix and go via several steps with loading, with preprocessing, features engineering, clustering, finishing with cluster markers, identification. And as a result, the aim is to get a report in the PDF in quarter. You can see two colors because the same steps has been implemented into the same, let's call it, pipelines. For the green one, which is based on Nextflow, you need Nextflow and the Docker image. Then the pink one, it's when I will call it a targets pipeline, needs some R with the renv installed and a quarter CLE. So now I'll just jump into the change, actually stop sharing this part, and we'll switch to my RStudio window. Just a second, just moving down. Okay, Ring Central window and my RStudio. So basically, we'll be looking at both targets and Nextflow pipeline that I just presented to you. I'll start with building my my Docker image. As you can see, I have already been doing it multiple times, so a lot of things is cached and it saves us seconds. I know that building your own Docker image might be a bit of a time-consuming and painful, but believe me, it will pay off later on. So yeah, just use it. Okay, and my pipeline is in the Nextflow pipeline folder. We have main. I'm having the config. I will go into details in a moment showing you. But in the meantime, I will just run it so it can already be processing. And it's launched. And as you can see, it has 4 main steps with load data, process, expression, and render the report. So while this is executing, I wanted to show you the details of the pipeline. Starting with how it is structured. I have my Docker image. I do have my config where I defined every parameter and that on each of the steps that I would like to have. Moreover, my scripts that I'm using are scripts that I would be using anyway to make this analysis go, are stored in the bin with R, and if you can see, they are matched with the steps of the analysis, so data loading with the main process PMBC data with all Seurat functions that I will be using, not only filtering, feature engineering, clustering cells. So this is the main process, the main function that is using other ones that I would be using in order to get my data to the cluster, to defined cluster step. and how I would use it in terms of Nextflow as well. Moreover, if we go back and we see the main, you can see how the exact pipeline of mine is structured. So as I mentioned, there are 4 main steps, so 4 small bricks, starting with load data. So I'm defining any input, output, and the entire script that will be doing it, including the parameters that comes from the config file. Then my heart, so process data, and what I will be collecting from it is data, as well as some of the plots already that I will be using for my report to be included. It has several steps that I showed in run process script. It takes one of the RDS, and with multiple parameters needed, there is the output, desired output. I also put an expression data process where I'm going to only emit and collect plots, as it's taking, as the goal of it is to take the top markers and gene and visualize it with the heat map that I'm interested in. And also here I'm using some debug true functions so that I can also easily see that while running. And the final one is the process rendering report. As I mentioned here, I wanted to make it in Quarter and PDF specifically. So I can also define it over here. And now I'm putting all my simple blocks into a big tower with how we start with inputting our data, how we're loading, processing, then processing further, collecting all that I need for the plots, and rendering report in the end. Easy as that in terms of Nextflow. In this case, I'm using only R script, as all my analytics are in R, as I'm using Serret. But if I would like to expand my workflow, my pipeline, I could also define some processes in other in Python, or even add some tools before, after, and expand the workflow that I'm looking for. So let's see how is the pipeline going. You see, everything is done. We have all ticks green. It took only 3 minutes and 50 seconds. So while I was talking to you and sharing you, everything was done. I don't need to go step by step, running each script one by one. I can just also make it in a queue and process many samples. And if I want, also can go further with parallelization and resources management. All my results are stored in results, where I defined it as my output directory. I wanted to collect RDS, as maybe I would need it, report in PDF, and some of the intermediate plots that I will be interested in those as well, especially that some of the steps include might be also include some plots that I would be investigating on some early stages, and I might be changing some parameters when I see the results. And if some of those processes will be shared, I can also do some resume if I need it, or my pipeline will be failed. Then I can use the resume option to not starting from scratch. It's very helpful when you have long pipelines, something is going on, it fails, and you don't want to start from scratch. You're just starting where it fails, and it's very helpful there. All right, this was Nextflow, but let's look at the target pipelines. I have it prepared in my targets pipeline. I do have the main targets. I do have my config in YAML, and also I have my R scripts. And as you see here, I also have some additional ones over here that it's not included, and I will be changing the pipelines while we are talking. Yeah, I do have my quarter, my range, so everything is there. So let's look what we have here. The same config as well as with the parameters that we would like to have as small different R scripts that I will be using, and the main targets a file with setting first the options or packages I will be using, then loading the scripts that I would like to use, and then building my targets with the list of targets, starting with how I want to get the file, how to process it. Then after loading, if there is any metrics that I would like to plot or process, and these bricks are chained as I would like, as I designed the pipeline to be, so they are not in random order. And we're finishing with the quarter report to be included in the end and rendered. Okay, so we have several steps over here, but if you listen to me carefully here, I'm finishing on process PMBC, so I don't have any expression, or let's call it find markers steps. So yeah, it would be good to add it so we can actually have it. So let's see what we are missing in terms of data loading. Nothing, but in process PBMC, you can see that I'm finishing with the features engineering and PCA, and I don't have anything related to clustering cells. So finding neighbors, finding cluster, and running my UMAP. So let's just include one of the functions that I have been using in the other ones. Yeah, so let's do the cluster cells. This is the same one that I had in the Nextflow or in the other scripts that I have locally. So I have my cluster cells, but let's look at the master function that will be doing it. We have filter, normalize, and features, and we are missing the cluster cell one. So let's add it over here. And now we are going to have it, but we are taking resolution as a parameter. So we need to add resolution over here. So, okay, so we add another step in our process data. We have clusters, we add the resolution, which is awesome. But remember that we are using it parameters. So let's come back to YAM and add those additional parameters so we do not forget it. Resolution, and I will add 0.5 here. All right. So we already have the resolution, we added some new processes, but this find neighbors, find clusters, run UAP, it's giving me a bunch of nice plots. So I want to add them inside the plotting. Here I have only some scatters, some violent plots, but I know that I will need some UMAP plot from running UMAP, and I want some violent plots and some reduction plots some feature plot in order to investigate particular markers. So let's just add some of those here as well. And these are the functions that I was using in Nextflow as well. So I'll just copy paste them or type wherever you like. Okay, so we have plotting, we have it, but another thing, we are using another gene over here because we will be interested in particular gene to be used. So let's do data visualization. that's our data viz. And then let's say gene will be MS4A1. Okay, we have it all. Okay, so we added some plots, we added some process, but we added within the small bricks. Also, the another is find markers. And this is a simple R step, R script that I use to pick some markers, then show top 10, and using the Seret function do a heat map of it. And this is in the different source. But I have already copied it over here and put it in my R folder within the targets pipeline. So we need to remember, and now we're building our pipeline, that here we will be using another script because we want to add another block with find markers. So let's go now and go with, we are loading data, we have processing it. First, process PMC. Remember that in process PBMC, we talk rows, we have several parameters, and we added here one more, which is the resolution. So we need to add it over here so it's not missed. And after that, we have already added some visualizations. So we are going to build and add another chunks, another blocks in order to get it. So let's do some UMAP visualization. So what we are going to do and what we need to be as an input and then. Okay, let's do some font markers, including also the parameter gene that we were looking for. And the last thing is, will be the heat map that I'm looking for in order to have my markers. All right, okay, double checking. We changed we added some new steps in our pipeline. We have in conflict additional parameters. We added functions that we are using for clustering cells. We wanted some other plots in the plotting, and we used another function, another script for finding markers, so adding the entire neck steps. Okay, so what else is our report template? Let's look at it. You can format it wherever you like. It's up to you. This will be a really basic one. So we start with loading whatever you want to load in terms of what to visualize, and then with chunks you can go with simple as the markdown, as the Quattro file. I do have it already typed, and it was easier for me to do rather than just typing it during this talk. So basically, you just then add whatever you wanted to add in your quarter reports. It's up to you. Okay, now, so let's switch to and go to the terminal, and let's make it working. And keep your fingers crossed, because I already have some error, which is absolutely where you will go. And let's see. Import scripts. Okay, let's see where I made the mistake, and I guess it's somewhere here. Is it 88, 89? Okay, I like live demo. Something. Okay. Is it now? I think I have too much of those. An extra line. Thank you for helping. But I think I got lost. If I can. Okay. Let's find it matches. I love it, but if you see it something that I don't see, you can always help me out. Isn't matched. Isn't matched. Target is like 73. Yeah, here. Yes, it has. Yeah, right now, I guess it's good. Thank you, Alvaro, for helping me out with that. Always a help. Oh, no. Okay, saving will be good, right? Okay. Now, please do. Yes, it's going. I skipped some branches because they already have been done. You can see that we go with the processing, with normalization and calculation PCA. Some UMAPs is going on and using it to get the features in the class test. Of course. So let's wait a bit of seconds. And calculating, there will be clusters, and you can already see, like here. Also, we need to wait a little bit to finish. So I would jump to give you like advantage of using the pipeline. If you're good with that, with the run, you're just closing it and forgetting and waiting for your results to finish, not just waiting for one step and then going with another and another further. Okay, so let's give it a moment. In meantime, I'll also go through the other site for that, and as I said here, I will be collecting the report in the PDF. But if I want to have any other files as well, can also define it to collect. So let's give it a moment, and we will be further. And I can ask this over. I can already look at the chat, the code being presented on the GitHub later on. I've noted that some of the version is already. I'm not sure if it's publicly available. We need to double check and also push my latest changes. And if possible, I'm using public data set, public tools. So I don't see at this moment any blockers to not make it public. Okay, let's see. All right. Okay. So we have the last part with the, not the last part with the UMAP visualization. We go with violin, then now it's just looking for the markers, and then we'll go with the visualization and the quarter report. So let's give it a moment and we'll be down. So as you can see, it's just a small data set. But already taking some minutes. Imagine that you have a bunch of bigger one, and it takes time and takes your computational resources as well. And that's why the pipeline is your lifesaver here. All right, let's give it a moment. Maybe there is another question. If you want, I can already ask them in meantime. Okay, I don't see any, but maybe you have you want to see any particular script or anything related to the pipeline. And do you always use RENF when working with targets? I will answer it, Vivek, that I always use RENF when I'm working with R generally. In every project, no matter if I'm working with targets of anything else, and it's really helping me with the environment and the dependencies and especially when your packages also versions are really crucial and important in terms of any analysis you are doing. So I strongly recommend to use it, and make some friends and RENF is your friend 100%, and it is a lifesaver, not only in targets but in general. All right, okay, we have our with our pipeline. You can see like 4 minutes, so a little bit longer than the Nextflow. Everything is in the PDF. It includes some visualizations. Let me just open the PDF, and probably I need to stop sharing this particular screen in order to show you the screen, the window, and share. And of course, it's a basic win. It's just to show you the visualization that can be included, and you can format it as you like with all the features that Quarto gives you a chance with. Make it looks good and how you would like to have it. All right, so now I'll be switching to another window, which is the presentation. And let's move forward. So we saw the pipeline, we saw the benefits. I showed you a lot of things, and you might be asking why, when to work with. So targets and Nextflow. The construction of both pipelines, especially, the main file, it's similar. It has also the same context or like concept of chaining small things into a large one and execute it and manage it. Also, you can configure both pipelines with the config, all Nextflow, and the targets. Some differences in terms of that could be also important for you in terms of operation when it comes to Nextflow files and values and targets objects. Nextflow with its supporting Docker singularity containers, in my opinion, have higher level of isolation and reproducibility, while the targets is dependent of the environment and if you have necessary software installed. Then when it comes to larger projects, especially when you have different tools and software, different tools and languages, Nextflow is your friend here. When you're good with solely R projects, R script, targets will be also great and do the job. And I think that Nextflow is easier to extend the pipeline. For example, here you can go with in the beginning, in the end, or trying to include some different methods. In target, it's possible, but I think it's harder to debug, as I also find Nextflow community support and documentation very well done, and will give you a good start and learning curve to start with your analysis. So when it comes to targets, if you work for R-centric, If you're looking for reproducibility within the R environment, if you have many dependencies, you want to execute it correct order, you want to update your task, you want manage the dependencies and the workflows, and you have multiple independent steps. You are also doing some POCs or some updates, and you want to check targets, works really good with also rerunning the parts of the workflow, saving you not only resources but also time. And it is useful for large-scale data analysis with large data sets, giving you some execution capabilities, distribution, and speeding up the processing and analysis. If you're looking for something different, slightly different, when you have complex, you have diverse tasks and tools, various softwares, and you want to chain it into a single pipeline and handle different languages, here where the Nextflow has its advantage. Also in terms of processing and distributing tasks and using the cluster and cloud environment resources efficiently and effectively, with this native support for cloud platforms and how the resources are allocated. So if you're looking for something scalable and cost effective, that will be a good choice as well. Error handling, as I mentioned, documentation, retry mechanism, the same as in targets, it's already there. And the big plus with the container like Docker, Singularity, making that the environments are consistent and you are minimizing the risk of any kind of discrepancies due to the dependencies, configuration, and also minimizing the risk that it might impact your analysis and your results in the end, which is not only within the life science, but also across the industry as well. So regardless of if you use targets, Nextflow, both as their pipeline, they offer you powerful capabilities for not only building but also managing and executing your data pipelines. If you're heavily invested in the R ecosystem, you can live with its limitations, choose targets, and go. Opt for Nextflow if you're looking for cloud integration, some robust multi-language support, and large-scale data processing. This will be a great choice of yours. So regardless of that, just get started today and use pipelines to drive your research to success. And thank you so much for joining today. I will be ready to take any questions you might have.
All righty. Thank you so much, Aga. That was so wonderful. I had like questions planned for you, and then you answered all of them regardless. So, thank you.
No, I don't think so.
Well, okay, let's like go with one in the meantime, and then we can wrap up. So, why is Nextflow preferred over other tools like Airflow or Targets when managing pipelines in the life sciences?
I wouldn't say it's preferred, but it's heavily used. It originally was kind of designed for managing complex bioinformatics workflow. So it originates with this concept and idea. So I would say that it has its robust capabilities and also great support, how the community has started and grown. You can also have a look at the NF core pipelines that are developed within the community, and kind of like each of the very well-known and widely used analysis has its NF core pipeline that you can easily give it a try and even then use it for your own research ideas. So, for example, the widely used is like RNA-seq. It's like a total gold standard. And I think that it's developed and developed so much that it covers a lot of bioinformatics questions and problems and how it is managing the complexity, not only on terms of the data, but also the tools and software that is available, meaning R, Python, both languages widely used in life science. Then you have different tools for different analysis or data within the omics and beyond, that they are written on different stages and analytics. So basically, I think that it gives you a chance to mix different tasks and softwares, which in targets you are somewhere within the R ecosystems. And sometimes for some analysis, it's not enough and you have to go beyond. What else I would have for Nextflow is, you can easily start and build with the documentation, I guess with targets as well. So it has good, like, let's say, a support, and if you want to start, it's easy to do so.
All right, thank you. And then we have a question from Alvaro.
Regarding speed,
Yeah.
it's faster. I mean, if we do this kind of rough benchmark of me running it, then I will see like Nextflow has 3 minutes when Targets has 4. And this is the same workflow. I mean, it has the same steps. So this rough benchmark goes with Nextflow. But I haven't tried it actually to compare in others, even more complex one. Yeah, and Pasha is answering that they should perform the same, actually. True, but maybe, you can tweak something in Nextflow that will make it quicker. Yeah, so more or less the same. But if we try to change, then I would go with Nextflow, to be honest, in terms of also supporting the performance and the things that you can do there to even improve it.
That makes sense. Mm-hmm. All right, thank you.
I would just, you were right. Don't perform the computation in the end. Yes, because it's done within the R scripts. Yeah, but the orchestration also have some in-betweens that has to be done. So maybe that's also a case here.
Okay. Something to find out.
We can do a benchmark, I mean.
Yeah. All right. Thank you so much, everybody. Thank you so much, Aga, for the talk. And thank you so much, our audience, for being here till the very end. When the recording is available, it will be sent to you through email, and it will soon be uploaded to our YouTube channel in case you want to follow up with the code and everything else. So if you'd like to find out more about our community and the next Shiny Gathering, you can join our community Shining for All using the links I will be sending in the chat. And we also have our weekly newsletter that will help you stay up to date on everything we have going on within the Shiny community and in Appsilon. And also you also find cool stuff that Aga is working on, because we have a really cool video coming out very soon. So Aga, quick question, where's the best place to find you?
Oh, you can find me on LinkedIn, obviously. You can find me looking for me as, Aga, exactly. Gigi was
send the link in the chat.
Like a rocket on LinkedIn. You can also try to reach out to me via the email. So, okay, that was typo. I was trying to be faster than Gigi, but I don't think that I will win this competition. But here we go. That's my email. Anyway, LinkedIn is the best place, or via the email. And and also look forward to any other talks that I'm doing within the community. And thank you for having me today.
Thank you so much. All right, that's a wrap, and we'll see you in our next Shiny gathering. So, bye-bye.
Bye. Thank you. Have a good evening, afternoon, wherever you are.
So many. Bye.